All right, so next, shake your axis. Jennifer McGuire, come on up. She's representing a larger team at UC, and I'll let you take it away.
Hi, I'm Jen McGuire. I am here to represent Shake Your Axis. Oops, it went too. And this is a prosthetic joint for the atlantoaxial joint. And so before we really get started, I'd like you to kind of loosen up. And then I want you to hold right here. Now imagine that's permanent, and that's how it is for the rest of your life. And imagine what that limitation would be. You can't drive anymore. Imagine being in a crowd. Imagine if you're a child and you've got the whole rest of your life like that. And so that's the problem that we want to address. The atlantoaxial joint is made up of the first and second vertebra. The first vertebra is a ring, and it sits on top of the second vertebra, which has that little point sticking up, and that literally is the axis of lateral rotational movement that looks like that. So when there's instability in that joint because of illness, lupus, rheumatoid arthritis, some types of cervical damage, or some birth defects, the treatment option of last resort for severe cases, which are potentially life-threatening, is a complete fusion of the skull to the cervical spine, usually the first and second vertebra, but sometimes the third vertebra as well, which gives you that kind of motion. So the product that we want to develop will be revolutionary for these patients. I mean, it would be a dramatic improvement in the quality of life. It is absolutely different than anything else that's out there. The reason that industry hasn't really shown any interest in this is because there's only about 10,000 people a year that need this surgery. And that isn't a growing number. This isn't an expanding market. Ideally, it's a shrinking market, but that hasn't really been the case either. And so there isn't really any much money to be made in this, and these are commercial entities. So we are looking for other sources of money, including the Public Health Service and potentially Department of Defense. So our prosthetic is actually made up of two pieces that includes both the first vertebra and the second vertebra. The first vertebra, we remove part of that ring and add this metal plate. And in the second part, we remove part of that piston and add a piece that will click into the top piece. And that's then attached to the skull so that you lose this range of motion, but we ideally will preserve the no range of motion. And our goal is to have at least 50%, 50 degrees in each direction. So normal movement is about 90 degrees. So here's where we're at in this. So we have the initial design. We are starting to do some virtual testing on the biomechanics. We don't have a physical prototype. That's where our obstacle is. And we hope to be able to get that and to start moving on into getting external funding and testing in cadavers in the next year. So here's our obstacle. We want to do additive manufacturing with titanium metal. The printer at UC is indefinitely offline, and we need to find an outside source to actually make this prototype. We also need some guidance in the type of mechanism that we want to apply for. So the NIH has a mechanism that functions almost like a small business grant, but it is for academia. This is a different type of grant than I've ever written before, and so having some guidance on how to really sell that to this entity would be very helpful. So I'd like to introduce you to our team. So John Forbes is assistant professor in the Department of Neurosurgery. He is an expert in minimally invasive skull base surgery, and he's been working on this actually for a few years now to develop the prototype, to find the surgical corridor to get it in, to start determining what kind of instruments need to be done. And so he's actually got all of that in place, but now we're at the physical prototype. Sam Anand is a full professor in the Department of Mechanical Engineering, and he is an expert in precision manufacturing and additive manufacturing, and he really is going to be the person that sort of drives this physical prototype forward. He's the one that's doing our virtual testing right now. Oh, and then there's me. I'm the cheerleader of the group. I'm assistant professor in the Department of Neurosurgery, and my experience really is in the grant writing and kind of the foot on the behind part of things. And so I would be delighted to answer any questions that anybody has.